G'day viewers. Yeah, here we are so far. We're starting to strip the machine down. I can give you a look at it now, as everything's easy to get to. This Z-axis plate, I designed that 5 years ago and sent it off overseas, got it made up. They made quite a few for me, did a really good job. I was actually going to buy one of those ox routers, build your own. I was very interested in that, but I couldn't get the parts. I've got half the parts here to build a ox machine, and I just could not get the parts. I was waiting. So anyway, the story goes, couldn't get the parts. I thought, I'll build my own. So down here we've got 20mm rails. These are supported linear rails, if you don't know. These are 16mm rails here. This motor here is only a NEMA 17. Very tiny motor, but it's got a big reduction on it, 5-to-1 reduction. Same as the X-axis. This is the Z-axis. It's called a Z40 because it's only designed to have like 40mm travel on the Z-axis between the router bit and the table. It was the main purpose. It was designed for doing electrical labels for switchboards and make circuit boards, but it became, as you can see, I cut a lot of aluminium on it. It cuts aluminium quite well because the axes are so solid. If you have a look at this, that part there, the X-axis, the main gantry beam, that's off a Toyota bull bar. Yeah, that Toyota's not driving around anymore, but I scabbed that bit out of the bull bar and had a guy cut it for me. Didn't do too good a job. It's a bit crooked. So yeah, there's me. That's me circuit board holder. I just whack the circuit boards in there, holds them nice and tight. And the main point of this machine is how robust and how strong it is. I'm shaking the whole table. There's no movement. There's zero backlash. It's this is all Taiwanese stuff. A lot of the stuff I'm getting now is from China, and it's pretty good. But this Taiwanese stuff, it was very, very expensive when I built it. It cost me a lot of money to build this, way more than you could get a cheap machine off of eBay. And this is my little control box. It's an old switchboard, come out of a sugar mill down there at Rocky Point. And as you can see, it's a lot of corrosion in it. And this board suffered a lot of damage, and they didn't want to use it again. They wanted nice new sealed switchboards, as you would in a factory with a lot of dust and dirt and rain coming inside the building. But yeah, so I'll give you a sneak preview of it might be a little bit of overkill. This was designed for a bigger machine, right? It's not just this little tiny machine. This is eventually going to go on to a bigger machine. So you've got 3 power supplies in there. I just whacked this one in. That's just testing that one out. That's supposed to go under here. That's only a 48 volt 400 watt for the spindle, but it's also powering these motors at the moment because I've got a 1000 watt for this. So this power supply is going to stay with this machine, and the bigger power supply in this box will go to the other machine. But there's a little PLC there. There's a dedicated 24 volt, and up here there's a separate 12 volt that powers a light on the gantry, and it also powers the breakout board. Now this breakout board is from Mac Drives, as they're an Australian company. Beautiful beautiful boards. You see I've got the emergency blocked out there. because I've got a different safety system here. I've got a tamper-proof, double redundant safety system there, and the PLC, that's not even, well, that's only working as a delay timer. It gives me a little bit of delay time. By the time you power it up, it lets everything get settled and then powers it up. And we've got a couple of relays down here. Yeah, this will be a lot tidier when we whack it into the bigger machine. But before I build the big machine, I've got to finish this machine here. Very happy with this design. It's something that I've come up with myself and worked and pulled it apart and redid it. And there's a ball screw there. I was just sussing out the different ones for here. I chose this one in the end. So I'm going to put longer legs on and maybe even put finished CNC finish on them. But yeah, this was a mistake up here. This is what we call articulated cable trunking. I've heard so many different names for it, but in the industry we call it articulated cable trunking. That's what it's called. It's not caterpillar tracks. It's not drag. One guy said it's a drag line. I said, mate, if you knew what a drag line was, you wouldn't even get one in your house. They're huge. They're big giant machines, drag lines. Yeah, there's me. That's my little X-axis motor, and there's one of the Y-axis motors down there. You can see. Yeah, so we're stripping it apart. New bed or new table, whatever you want to call it, deck. New gantry legs. Don't know if we're going to change the gantry yet. This is a really good design. I'm really happy with this. If you want something really, like I can do millimetre size, 1 millimetre size engraving in steel. I didn't try it any smaller. I was just blown away that it could do that. So yeah, that's this is all do-it-yourself stuff. I knew nothing about CNC. I'm not a machinist. I'm not a welder. I'm not an engineer. I'm an electrician. I'm an industrial electrician, and that's my job. That's what I know. So I'll show you some stuff when we're building this. I'll show you some stuff that might sort of open your eyes up and give you some guys of maybe a few different ideas. And because I like sharing my ideas, and I like looking at other people's machines and seeing what they do. And yeah, I was given all this plate to start with. I think I was given like a third of a sheet of 10mm plate, and it was 5083 alloy, very, very strong alloy. But you want to talk about alloys, when you're building your machine, consider the type of alloy you're going to use. This stuff here, this is nearly, you look at the specifications of this metal, this is nearly as good as titanium. This is a 7000 series aluminium. You're battling to buy this stuff. And it's anodized. It's anodized that gold color, and so it should be, because that reflects how much it cost. It's very strong. It's like you try and drill a hole in it. It's like drilling steel. Well, not quite, but it's almost as hard as. But the lightness and the rigidity and the quality of the finish, I won't use anything else but these sort of plates in my Z-axes. So looks like we might go closed loop steppers, maybe 23 and 34 series, which means I've got to change this whole back plate here. Now, that was handmade, that one. That's a bit rough. This little 17 motor, we're going to put something like that in the 23 scale, and I'm not sure if I'm going to keep the gearing, or we'll see how we go. It's beautiful, but it just slows it down. This is not a speed machine. This is a solid machine that does slow work but very neat. I had a lot of problems. I had some crazy stuff when we first started. Like if you're only just starting out with, you know, say if you're going to build a CNC, the first thing you got to make sure is your printer port is set to EPP. I had trouble ages ago, and I thought, what's going on? It works on the other machine, doesn't work on this machine, and it was simple, just a choice of selecting the right printer port mode. But yeah, so we'll strip this down. We'll start building it. I'll do a few videos as we're going along and show you all the changes, and hopefully we'll make a way better machine than what this one is. Like I said, this one engraved fine and it did labels fine, and but we want something a little bit bigger, extend the y-axis out a bit. They're only 500mm rails. I'm thinking of maybe 800 or a metre long rails. Don't know if I need to go any wider. I just need a bit of length there. And we've already changed this Z-axis. This only had like a 100mm. It only had like a little 100mm ball screw in it. So funny. I'll show it to you in the video next time. It worked fine. It was just for up and down and doing little tiny jobs, low profile stuff. But now we want to get into much higher clearance, so do bigger jobs, and want to add in a 4th and 5th axis, which will be fun because, like I said, I'm not a machinist. I'm not too bad with G-code, but I'm not an expert by any means, so don't expect me to. I'll tell you basic stuff about G-code, and it's very easy. The basic stuff is easy, but it can get. It's like education. You got your primary school, and you got your high school, and then you got your university. Well, I'll probably be at the end of primary school with me G-code. Yeah, so that's just a bit of a video for whoever's interested in what I'm doing, and let's see how this one turns out. That's the little spindle. These are amazing. 400 watt spindle, as you can see, 12,000 RPM. There you go. And you can do magic with these as long as you're patient. So that's it. That's 5 years of my CNC experience. A rough, this is what you'd call a rough draft. So now we're going to attempt to build a professional level machine and have a better box and wiring and stuff. We'll probably keep most of that stuff and maybe whack an e-stop on the front of the machine, a few other little things. Anyway, thanks for watching. Make some comments, whatever. Have a good day. See yous.